of you like math? Okay, that's actually a bit more than I expected, which is entirely understandable. But I would assume for the greater public, this is why you would call math mental abuse to humans. I personally very much agree with this designation, as I think it's a perfect representation of what goes on in a typical high school algebra class. And I say this as a person who very much enjoyed my algebra class. After all, the only thing most people remember from it is this algebraic monstrosity. Jokes aside, the quadratic formula is emblematic of what most people think math is. You plug numbers into this equation, you get an answer. There is normally only one right answer, only one right way to do things. This is how math is taught in schools, how math is represented in media, and how math, I understand it, to be understood by most people. This is wrong. This is not math. Throughout history, mathematics has actually been more closely intertwined with philosophy and the arts than with the cold hard logic of science. Given that the current scientific framework we currently use has only existed for about 400 years, this is quite understandable. But the study of numbers is older than that. The first known written mathematics system was invented 5,000 years ago in ancient Mesopotamia. The Sumerians and Babylonians made revolutionary advances, and the ancient Greeks intertwined math with philosophy in a way that still exists to this day. Pythagoras himself, while now known for his eponymous formulas, was considered a philosopher in his heyday. In fact, he was so much a philosopher that there's a myth going about that he actually hated beans because he thought they were related to human fetuses. That's an interesting side note, but Plato and Aristotle were also philosophers as well. But today, I want to prove to you that mathematics is an art form, that mathematics has beauty inherent in it, that math deserves to be treated as a subject in its own right instead of as a tool to be used. And to do so, I want to use a mathematical proof, so to speak. A proof is, in essence, a logical explanation for why something is true. And all proofs have three categories. Number one, the starting assumptions, where you start. And then, of course, you must have where you end, your logical outcome, your ending outcome. And then there's, of course, the journey you take from the start to the end, and that's your reasoning. So the structure of a proof can be best summed up like so. If my assumptions are true, then, because of my reasoning, the outcome must be true. Imagine a skyscraper. What's a skyscraper normally made of? Like metal beams, glass, drywall, maybe some electrical wire, so on and so forth. So if we take an analogy of building a skyscraper to the making of a proof, then our starting assumptions can be considered these metal beams, this glass, this drywall. The blueprints for the skyscraper, the making of the skyscraper designed by the architect, or in this case the mathematician, is our plan, the mathematician's plan for how the proof is supposed to go. And the workers performing the act of calculation, they're just putting the proof together. This calculation is what we are taught in our 13 years of public schooling, but it's not the full piece of the puzzle. And then we finally end with our finished skyscraper after a few months or a few years. It stands proud and tall above the rest of the city, and the pedestrians walk by, maybe look up at it and say, "Oh, cool, that exists." But, you know, skyscraper cannot stand without each of these parts working flawlessly. It cannot stand without each and every step of its construction working together to make the finished product. In the same way, a proof is not logically coherent if its individual parts do not work. Now, applying this to our own problem, we must figure out how to prove that mathematics is an art form. How do we do this? Well, we know that where we want to end, that math is art. so our outcome is taken care of. Our reasoning doesn't come yet because we still don't know what our starting assumptions are. So in other words, the question we now need to address is, what is art? When I was researching for this talk, I found a lot, and I mean a lot, what art is. Said that art was anything made by a human, and there were other people that said that art had to meet this incredibly specific criteria that seems to be extremely Western-centric. So I decided to make my own definition. In my observation, art has 3 things inherent to it. Number 1, it must be human-made. I don't think it would make very much sense to say a pile of sticks that a chimpanzee created would be considered art. Maybe to them, but not necessarily to us. Number 2, art must express some form of idea. And number 3, it must have inherent creativity or imagination. In my observation, mathematics fits 2 of these things pretty well. Like, it's made by humans, and it expresses ideas. Whether or not we like those ideas, of course, is up for debate. Disliking the outcome of an equation that you've gotten wrong, that's happened to all of us, I'm pretty sure, at some point in our life. But the question in the room, the elephant in the room, is whether or not math involves creativity. Creativity appears to be the antithesis of everything that math stands for. Math is fully axiomized, it is entirely logical. If it does not fit in it cannot exist. But consider this. Those philosophers I told you about earlier, they considered math not as something to explain how the world worked, but to explain how the world should work. They deal with objects that are real, it deals with objects that are imaginary. Good luck finding a perfect circle in nature, or anywhere in the universe. But a perfect circle can always exist in our heads. And that circle's quite useful. We can use it to describe how the wheels on a car rotate, how planets move around the sun, or even the difference in size between a 14-inch and a 16-inch pizza at your local Domino's. After all, we all want to know what the best bang for our buck is. So when we consider that mathematics is nothing more than logic applied to the products of human imagination, this becomes more feasible. Take infinity, for example. Infinity is big. It's really big. But how big is it? So I had a math class the other week where this very question was posed to us by the professor. And eventually we were asked to prove that the number between 0 and 1 was in fact infinitely greater than the number of numbers that are considered natural. Natural numbers are the numbers we count with, 1, 2, 3, 4. Like, I can say I have 5 apples. It doesn't really make that much sense to say I have 5.5 apples, although some people might say that. But natural numbers are the stuff we use to count with. The proof itself was quite extensive, but the gist of it was we attempted to list all the numbers between 0 and 1 in order. Except we couldn't. Because no matter how you list the numbers between 0 and 1, there is always a number that is not in the list that is between 0 and 1. As you can probably see in the slide above me, the numbers outlined in red can be considered a construction. Containing the nth digit of the nth number all strung together does not exist in the list at all. And as such, you cannot count the numbers between 0 and 1, which makes them uncountable, as opposed to the countable infinity of the natural numbers. So if you can just imagine that you had all the time in the universe. Hypothetically speaking, if you had infinite time, you could count all the counting numbers. 1, 2, 3, 4, 5, 6, 7, 8, so on and so forth. But you can't do so for the numbers between 0 and 1. And this, I find, is extraordinarily interesting. Proofs require humans to look at a problem and say, how do I solve this? How do I show that this is true for all cases? How do I ensure that this will stay for posterity? This must involve some form of creativity, because I don't think it would be possible otherwise. The man who came up with this argument, it's called Cantor's diagonalization argument. I would consider him a genius, because this diagonalization argument has been used in a wide variety of areas of mathematics to this day. In fact, I would say that all proofs require creativity. Proofs are the building blocks of mathematics. All mathematical research is predicated on proofs, since pretty much time immemorial. Math research is not plugging numbers into an equation or designing computer algorithms to test every possible scenario, but it is thinking about how to prove something. This inherently must have some form of creativity or imagination involved. And because proofs are the building blocks of mathematics, we can definitively say that math fits the third criterion of an art form. Therefore, math is art. Of the public school mathematics education system, and just how we approach math in general. It might not matter to you or me as much as it matters to them, but we are inculcating in children, generations of children, a fundamental assumption and instincts to hate math. Because what we do is we do not teach math as a subject. We teach math as a tool. Mathematics, as considered by the curriculums that we study, is nothing more than a means to an end. We learn math for science, economics. We learn math so we can model how a tennis ball moves throughout the air. Mathematics education is not about teaching people how to do math. It is teaching people how to use math efficiently in scenarios that some arbitrary institution decides. This is wrong. If we consider mathematicians to be artists, we can compare the teaching of math to the teaching of other artists. We do not teach painters how to paint by stifling their creativity. We do not teach musicians music by stamping on their imagination. We should not teach aspiring mathematicians math by shoving boring problems down their throat day after day, week after week, month after month, year after year, so that they learn to hate what they could learn to love. Math is considered mental abuse to humans for a good reason. But if we consider math as art and teach it as such, maybe it wouldn't be so. Maybe as children draw as a hobby, they would learn to solve or prove hard math problems as a hobby. Maybe if it wasn't mandatory, then more people will seek it out. And maybe, just maybe, math wouldn't be considered mental abuse to humans